With no further ado, why don't you go ahead and take it over, Bennett?
All right, so a few preliminaries here. The talk does cover a lot of ground, and it's detailed packed, so I guess my preference would be to field questions at the end rather than in the middle, or else it will drag out quite long. The talk is informal. Many of the bullet points could be talks of their own. And so the points are going to be like 98% plus accurate. And I don't talk about the 2% exceptions to the rule generally. So just understand that I'm sort of speaking loosely about everything. There's no math, but I do assume that you have a passing familiarity with digital modes, such as FT8. So the talk in general is a little bit of an intermediate to advanced in content in that regard. See, the final point on the title slide here is that I do have a whole bunch of references and illustration credits, but they're at the very end of the talk. So instead of putting footnotes throughout the talk, I've just put everything at the end. And at the end, I've pointed to the page where the particular stuff appeared. Let's see, my video has shifted off screen again. Let's see if I can pull it back. There we go. All right, so. Okay, so this is sort of the agenda for the talk, and we're going to revisit this slide at the end. These are the things that I hope you'll take away from this. The 6-meter radio sports are very grid-centric and unique compared to other bands, or at least compared to HF. I found that 6 meters was modest station friendly. I have a modest station. I'm in a homeowners association. I have all my antennas in the attic, and we'll look at that in a minute. This talk has evolved because people at my club here in Williamson County, Texas, were aware that I had worked Meteor Scatter, and they kept bugging me about talking about it. And so I put together this talk, but I've also decided that I wanted to give it a little extra context, but I didn't want to limit it to just Meteor Scatter. So I do talk about not only Meteor Scatter, but Sporadic E, Tropo, and trans-equatorial propagation as well. I found that Meteor Scatter is quite involved, but it's exciting, and that 6 meters lives up to its name of being the magic band. So 6-meter radio sports is, as I mentioned, grid-centric. They're in this map of the United States. There's considered to be 488 grid squares in the United States. There's some details to that, but we're going to gloss over that for the moment. There's a sort of an award threshold called the VHF-UHF Century Club, VUCC. So you can qualify for this award once you've worked confirmed with Logbook of the World, if you've worked 100 grids. And then you can get additional brownie point stickers for every 25 grids beyond that. There are a lot of VHF contests, several each year, and they tend to be grid-centric. There's a particular award that's only on 6 meters, and it's called the Frisch Memorial Award, or FFMA. And we'll talk about that a little bit more on the next slide. Now, worked all states and DXCC and the maximum distance are all still very important, but beyond those, the awards are grid-centric. So here's a little extra detail on the Frisch Memorial Award. And so the deal is, if you can work all 488 grids in the contiguous US, then you can win this award. It was named after Fred Frisch, Silent Key. He was posthumously awarded this in 2008. And you can see that a dozen people have qualified this. I haven't checked in the last 6 months, 9 months or so, but there's only been about 12 hams that have done this since the award was started in 2008. And so this is sort of the holy grail for people to work for on 6-meter grids. An important way this comes about is from rovers or mobiles. They play a very important role in that a lot of these grids are very sparsely populated with hams. And so rovers will go out and activate those grids, and they'll announce this in advance, and we'll discuss some of the social media that's associated with 6 meters and Meteor Scatter. And so you'll often, if you're tracking those kind of groups, you'll know when these rovers are going to be hitting those areas that you haven't worked yet, and so you'll make a point of trying and to work those rovers. And of course, rovers is very popular with hams that can't have normal fixed stations, but it's also popular with people that do too. And it's sort of its own radio sports subgenre. I have not tried it, but it sounds like a lot of fun. So a little bit of background. I mentioned again that I'm in a homeowners association, and I've been a ham since '72. And I had long heard the term I'd long heard two things about 6 meters, but I'd never tried it before until just recently. There's always this mention that 6 meters is the magic band. And there's always this statement made that when 6 meters is open, you can work the band with 5 watts and a wet noodle. So I have an IC 7300, which I've only had for a few years. And before that, I never had 6-meter gear. So I never really thought about trying it. And even with the 7300, it certainly wasn't the first thing on my mind. But I had done a lot on FT8 on HF, and thought, what the heck, I've got this radio, it works. And I had the antenna means, and on a whim, on May 5th in 2019, I had a quarter wave vertical, had radials, and I didn't even set it up vertically. I laid it horizontally on my back porch table, and without even waiting very long, I worked Arizona in a few minutes. And with that, I got the bug bit me. I ordered a Moxon beam, and I have a 2-story house. We'll show the schematic of my house here in a minute. And I set the beam up on a tripod inside the house in my 2nd-story hallway on May 18th. And gangbusters. It turned out that this was a very fortuitous time of the year, which we'll get into in a minute. But for example, I worked Canary Islands at 4,700 miles on May 30th. In June, I moved the Moxon up into my attic. I put it on a TV rotator and ran the cable down into my ham shack in our media room. And I think I worked 20 states in one day, and I had hit the 100 grid mark within 2 months of me first starting on 6 meters. I had, getting my feet wet in 6 meters, I began to hear about Meteor Scatter. If you start, listening to the social media on 6 meters, it comes up quite a bit. And so I tried it out, and on August 13th of 2019, I had my first 6-meter Meteor Scatter CUSO. So this is my antenna farm. And like I said, I'm in a homeowners association. I happen to have a large house. It's 2 stories, and it happens to have a very large attic. And this is a schematic representation. I just took this picture perhaps off of Google Earth. And the dormers aren't to scale here because it's a picture from a low angle on the street. And schematically in yellow, I've shown the different antennas in my house. So what I'm trying to show here, the front yard is at this base in the lower right, and the boundary between the 2nd floor and the attic is about 25 feet above the front yard. It's a little bit less in the backyard, and the attic's about 14 feet tall. I've got discone over here. I've got a 10-meter halo at the very peak of the roof. I've got a the 6 meter Moxon on again on an antenna, TV antenna rotator. I've got a 2 meter Armstrong rotated 10 element beam. I've got another vertical, and I've got a old vent pipe that I've converted into an HF antenna, which actually has done quite well. So here in the center, this one horizontal line in the center is sort of representative of the height of the backyard, and this 6 meter vertical, I mean, this first dashed line is a crude representation of the dipole that I first worked Arizona on. And then up here at, the schematic representation in the second floor hallway was where I first put the Moxon on a tripod and worked Canary Island. So I think, I never would have predicted I could have done any of that before I tried it. So here's my current status of worked grids. This is using the Grid Mapper utility, and all of the grids in green are Logbook of the World confirmed. And the ones in red I've worked, but they're not confirmed. So I've got, of the 448 grids for the Fred Frisch Memorial Award, I've got 304 worked. But of course, these are the ones that aren't worked are in very sparse areas of the country. So I've got my work cut out for me. You can also see the outside the United States, I've got 74 DX grids, and I've circled in red some of the ones that had the largest distance. I've worked Hawaii at 3,700 miles. This was the Canary Island, 4,700 miles. And then about a month or two ago, I worked a station in Uruguay around 5,200 miles. I've worked 49 states. I have not worked Alaska yet. And of course, I'd love to bag that. I've worked 15 states so far on Meteor Scatter. We'll get into the details. I consider myself an advanced beginner because there's certainly a lot more to know about Meteor Scatter, but there's a lot we'll find out today. The lower right here shows, of course, what the VUCC certificate looks like, and then the lower left, not to scale, is what the sticker looks like once you pass 350 grids, and you can apply that to your certificate if you want. All right, so let's talk about 6 meter propagation. I assume the audio is still coming in fine there.
Yes, sounds good.
All right, so just to recap very quickly about ionospheric propagation. There's a continuous electron density variation in the ionosphere, and these are abstracted as various regions that we refer to as the D, E, F regions. And the extent of refraction of our radio waves is a function both of the extent of ionization and the frequency of the radio waves. And the F layer ionization, which is a strong function of the 11-year sunspot cycle, is key for HF propagation, the F layer and the F2 layer during the daytime. The maximum USO frequency is the frequency above which refraction ceases to be useful for skywave propagation. And the point of all this chart is that even at solar maximum, the maximum usable frequency rarely reaches 6 meters. It didn't do much in solar cycle 24. I hear of the glory days of solar cycle 23, when apparently it did for a while. But even then, it's not like it's an everyday occurrence. So in general, 6 meters generally happens at the E layer or below. That F layer 6 meter propagation is a rare thing. So what is the main source of propagation on 6 meters? Well, there's this mode of propagation called sporadic E. And it's called sporadic E for a reason. It's sporadic, and it's not really well predicted, and it's also quite seasonal, as we'll get to in a minute. But it's a very big deal for 6 meter propagation. And the process is not fully well understood. There's a reference to clouds, sporadic E clouds. And there are many theories about how these came about. The predominant theory, I believe, is that they're meteor dust. and that but they're a function both of upper level winds and low pressure and geomagnetism. When the sporadic E conditions exist, there can be a wide range of signals. They can sometimes be very strong and they can last for hours, but they can also go away just as quickly as they come. This one graphic up here is trying to illustrate a double hop between the transmitter and receiver via sporadic E clouds. And theoretically, it could either occur from a central hop back down to the Earth, but there's often a belief that there's what they call a chordal hop, where it's passing from the transmitter to the first cloud and going directly to the second cloud closer to the receiver. And there's no way to know for sure, but I'm speculating that the Canary Islands CUSO I had on May 30th, 4,700 miles, was probably one of these multi-hop chordal sporadic E contacts. There are significant regional advantages to sporadic E that Europe is better than the Eastern United States. The Eastern United States has more sporadic E than the Northwest, and the Northwest has more sporadic E than the Southwest. Sporadic E, as this chart shows, in sort of a very abstract approximation, is strongly seasonal. So the peak sporadic E season is, as shown, centered around June, and it tails off quite a bit in the winter. Now, just because this shows a peak in June doesn't mean you can bank on there being sporadic E in June. Sometimes there's days when there's no sporadic E, but just statistically, the tendency is that you will have more sporadic E according to this curve shown here. Sporadic E is also has sort of a daily trend that it tends to peak in the late afternoon. It tends to have a little dip in the middle of the day, and then it goes away at night. Again, all these are tendencies that there's not really an absolute here. So here's an example. You're probably familiar with PSK Reporter and spots. And so this was an example of a particularly good day. It was June 25th, 2019. It was the first day I moved my Moxon up into the attic, and these are all people that spotted my transmit signal. That's not to say that a contact would have actually been possible with these people, but it's just a general indication of what how the band can open with sporadic E. Here's an example of another good day, just to show you it doesn't occur solely to the east, that you do get sporadic E that covers pretty much of the United States. I've worked 49 states, and most of it was on sporadic E. Those plots were for horizontal polarization, but you can also have sporadic E on vertical polarization. This was a plot using the previously mentioned vent pipe that I have. And what I found is that sometimes the signal will be stronger with vertical polarization, and sometimes it's better with horizontal polarization. Although if you could only choose one, I'd choose horizontal. All right, there's also another phenomenon called tropospheric ducting, and this is a weather-related thing. Basically, the basic idea is that the radio signal can tunnel or duct through between two different temperature layers, from a warm air layer to a cool air layer. This happens many times a year. It is random to the casual observer. I've read that there are prediction models based on winds aloft, where there are some people that can predict it. I can't. Tropo can last for hours, but then it can end just as suddenly. It often has very strong signals. Literally, you would think that the guy you're talking to is parked outside. It tends to be much stronger than sporadic E. although Sporadic E can be good, strong as well. You may be familiar with the, I'm probably going to mangle the domain name, but it's like MemoLink. There's a domain that tracks 2-meter propagation. And 6-meter tropo can track with 2-meter tropo, but it's not a reliable thing. But if I see, I usually have a window open to the 2-meter APRS tropo webpage. And if I see it there, I'll take some action on 6 meters to see if it's there as well. Now, this is, I think, variable by state quite a bit. I live near Austin, Texas, and there tends to be a fair bit of tropo in state. There tends to be tropo occasionally to Arkansas and Louisiana with some regularity, but for where I live, the big tropo ducting is to Florida. That there's many times during the year there's very strong paths between Texas and Florida that are believed to be tropospheric ducting. Another propagation mode is called trans-equatorial propagation, or TEP. And for people in the United States, this provides opening to South America. And this happens many times each year, although not reliably. And it's considered to be a double hop where there's equatorial symmetry. There tends to be a peak in the afternoon. I worked Chile and Argentina in April of 2020, and that was probably trans-equatorial propagation. It's felt that this could be the result of several processes. It may, in fact, be a special case variation of F layer. So even though I said there's no F layer propagation, this might be the exception to the rule, that when you see TEP, it may actually, in fact, be a form of F layer propagation. Let's see, Sporadic E and the comment here is that you'll find both Sporadic E and TEP on 10 meters as well. And sometimes it tracks with 6 meters, but it doesn't reliably so. All right, so this finally transitioned to Meteor Scatter basics. So the Earth is constantly bombarded by meteors that are vaporized in the atmosphere. And it's the vaporized trails that are transiently ionized, and they provide this fleeting radio scattering surface that enables exchanges, typically in burst mode. And that on average, there's, we'll get into statistics by month, but in general, there's at least 5 to 10 or more of these that are usable per hour, theoretically anyway. Most of these burst lengths are quite short. They last less than a second. Occasionally, there are those I've been told that last 15 seconds, not that I've seen, and that's considered to be a very long burst. There is sort of a sweet spot for propagation, and it's between 700 and 1,000 mile paths. And anything more or less than that is possible, but difficult. Let's see, in the lower right, the graphic basically shows that there's a cone that's established by the scattering, and the parabolic shape on the ground is sort of the projection of where that cone intersects with the surface of the Earth. And so that's theoretically where the transmitter can be heard in that area right there. All right, so let's talk about the basics of a meteor scatter CUSO. The CUSOs in radio sports tend to be quite minimalist. They're similar to how minimalists, they're the FT8 model of minimalism. And you must accomplish the exchange of call signs, signal reports, or grid squares, depending on whether you're in contest mode or not. And Rogers need to be exchanged. This is done via, if you're familiar with FT8, this is old stuff. in that there's a sequence of exchanges back and forth that has to be carried on. Try to put the laser pointer here. This line here in very fine print, eye chart test here, shows, you know, the typical exchange that you would see. There's typically 5 done, although it's reduced to 4 in contest mode, where we've got a CQ, we've got the initial call with the first exchange of a grid square. We've got a, well, the CQ had a grid square too. And then we've got a signal report, in this case, showing a -1. And then there's a Roger of that signal report and another return signal port of 09. And then we've got the double Roger 73. Now, the thing about meteor scatter CUSOs is each of those exchanges normally occurs on a different meteor trail. And the meteor trails are a random and intermittent process. So the timing of the trails is unknown. So the timing of that sequence is unknowable in advance. And part of the way to compensate for this is that these exchanges are coded digitally and are sent very quickly, as many times as possible in a given transmit interval. So to jump ahead a little bit, we'll circle back to it. So using the mode that's referred to as MSK 144, which uses 144-bit packets, each of those packets lasting 72 milliseconds, that is repeated close to around 200 times in a 15-second transmit interval. So to revisit that, so when I send CQ W4IMD EM84, when W4IMD sends that, when he's using MSK 144, that is packed into a 144-bit packet, and that is sent over 200 times in a 15-second interval. Then that's repeated until there's progress in the exchange. So, you know, W4IMD is going to keep sending CQ until he hears somebody talk to him. And then once that set of the exchange happens, that exchange is going to be repeated at each one of these stages until you know, we keep resending until we've got confirmation that that part of the exchange has occurred. So there are alternating times, as I mentioned, for meteor scatter MSK 144 mode. There are 15-second turns, if you will. For some of the older modes, which we'll touch on very briefly, there were 30-second turns. There was a mode called FSK 441, which I've never used. There was high-speed CW, which used 60-second turns for CQs, and it used 30-second turns for the exchanges after that. I've never done it, but that's what I've read. There's also a convention for, and if you've ever done FT8, you know there's an even and an odd period in which things are sent. And the same is true in meteor scatter. And basically to try to maximize the number of people that can transmit at one time without contention, there's a gentleman's convention that if you're transmitting to the east, then you're going to use the first or even interval. And if you're transmitting to the west, you're going to use the second or odd interval. And now this is just in the United States. I was watching a video about meteor scatter in Australia, and they're less east west focused, and they're more north south focused. So, you know, it's sort of a regional gentleman's convention. So you may gather from the previous slide that having a CUSO and meteor scatter takes a lot of patience and dedication. There's a very high rate of abandonment before completion. I mean, on the other hand, that can be completed quickly. You can be lucky, and they can be over quite quickly. But typical, you know, time length for a CUSO could be from 2 to 15 minutes to complete. But it's not unheard of for people to stay at it for an hour. You know, so if you're in a high in the high grid counts on the Frisch Memorial Award, and you're missing a grid, and it happens to be um, a grid that you're talking to be a meteor scatter, then you're going to stick with it. And or if you just, or you have the time and you're in meteor scatter, you're going to stick with it. But it's entirely up to the patience and dedication of the ops. One odd sort of thing that comes up in this is it's also possible that while you're trying to talk to one station, you can actually have a CUSO or one or more with other stations in between. And you can just pick right up and it's considered the same CUSO. When you call CQ, generally, what I would do is call for 5 or 10 minutes, give it a break, and then for maybe 10 or 20, and then pick it up again. So let's look at a example CUSO. And so I'm going to set up a video that we're going to look at in the next foil, but I want to talk about what you're going to see first so that you can get more out of the video. And this is a CUSO that I monitored. I wasn't involved, but it's between a station that's local to me, WB5TRL, and K0TPP. So what I've done, you'll see there's a red dashed box in the upper left, which corresponds, and you'll also notice that this screen looks a whole lot like an FT8 screen because it's using the WSJT-X software. And so many of the features for Meteor Scatter are very similar, to, if not identical, some of them, to the screen you'll see for FT8. And we'll be going into detail of the differences, however. But we've got the band activity in the upper left, and of course that will scroll up. And then at the bottom is what's called the fast graph that I've put a yellow box around. And what I'm advising you is to look at only those two boxes. Those are where in the video, those are where the interesting stuff happens. And there's nothing really interesting outside of those other boxes. They're not going to be highlighted in the video. So you're not going to see the yellow dash box and you're not going to see the red dash box, but I just want to draw your attention to it. And then we're going to drill in just a little bit deeper on what's going on here. And again, these are also highlights that you won't see on the video, but I'm doing them here so that you can figure out, learn a little bit better appreciation of what the fast graph is doing. And it's essentially a horizontal waterfall instead of a vertical waterfall. And but it provides a display of both frequency and signal strength over time. So as shown here, I've got the time arrow going to the right, and you can see the relative time is marked off from 0 to 15 for the 15 seconds in the transmit interval. Now, what I've done here is, and the fast graph shows 2 different 15-second intervals. So the box on the upper box is the current 15-second period that is real time. And then the lower box is the prior 15-second period that just happened. And in this green highlight area is a show of the signal strength. And in the blue background area, and now you can change these colors, of course, but this is the way I've got mine set up, is a display of the frequency spread. And up here is the band activity window, and I've got matching color boxes corresponding to those in the fast graph. So the time relative, for example, we had this long horizontal timeline and is in purple. Well, that same thing, same information is in the band activity window as shown in this purple box outline. The decoded frequency that's in the orange box, that's also in the band activity window in this coded area here. The UTC time in red corresponds to this box that's in the fast graph. Again, we had, so in this band activity window, you'll notice that the very top line is in blue, a sort of an aqua color, and that corresponds to The last thing that happened in the previous 15-second interval, while the last 4 lines shown here is what's happening in the current 15-second interval. And the reason there's more than one line is that they will display the first line shows the first time that there was a successful decode, and it was at a signal strength of 4. And if there could be further, remember the exchange is sent 200 times in this 15-second interval, and if it had not ever gone over 4, then we would only have a single line here. But every time the signal strength bumps up, it will display the greater decoded signal strength. So we can see that initially there was a signal strength of 4, there was a subsequent decode that was 6 dB, there was another subsequent decode at 7, another at 9. And so that's why there's 4 lines there. So with that, I think we can go on to the video. Let's see, I think there may be one more slide. Nope. Okay, so before we get to the video, I would recommend that you be prepared to ride your volume control. And the reason for that is that the sequences where we're monitoring the distant station, the audio is soft and weak, and you may actually want to turn up the audio. But when we're monitoring the local station, it's louder, significantly louder, and you might want to turn down the audio. So with that advice, let's go to the next foil, and I won't be talking much. There's some overlaid text that I've put onto the video, and it's pretty self-explanatory. So I won't be talking that much. We'll just watch the CUSO, which really doesn't take that long. Let's see. All right. So there you have it. That's what a Meteor Scatter CUSO looks like and sounds like. Hopefully the audio got through on that.
Yes,
Okay.
it did.
What's that?
Yes, it did.
All right, good. All right, so let's look at when meteor CUSOs can happen. Well, they can happen any time of the day and any day of the year, but there's definitely a seasonal trend. And this is a busy foil. I'll try to talk through things to simplify the matters. There's a distinction made between meteor shower rates and non-meteor shatter rates. And the non-showers are referred to sporadic meteors or random meteors. And the basic chart on the right is if you can just imagine or just focus on just the gray bars and ignore the red and the green stuff, that the gray bars represent the seasonal average rate of meteors over the year. And then and again, these are averages over several years. And so you can see right away that, for example, February, there's not that much in the way of sporadic meteor activity compared to July. That July and August have, and this is independent of meteor showers, just that the random meteors that occur not from meteor showers are peak in July and August, and then otherwise vary throughout the year as shown by the gray bars. So the meteor showers that I've tried to abstract in red here can modestly enhance these rates. And the triangles was just my crude way of showing sort of the peak addition and to show the time period that these, don't happen on just one night, although there'll be a night that's the peak and is associated with them. So for example, if you look at the bar for August, you see there at the top, there's the Perseids meteor shower, and there's a date there that's August 12th. And so generally the Perseids meteor shower peaks on August 12th. And then the base of the triangle was my attempt at showing that the shower itself is actually spread out over the entire month. And again, the size of these red triangles, again, are averages, that there's no guarantee that a given meteor shower will produce this number of meteors in a given year, that it varies from year to year. And in fact, what the green lines show are some historical peaks. So even though I said that, February wasn't a very good month, it turns out that there's this little minor meteor shower, the Delta Leonids, that on one year, I didn't write down the year that it happened, but the peak year in the last 10 or 20 years, that the rate shot up to close to, above 350. So again, there's sort of a, luck of the draw of what year you're operating in terms of what the meteor rates would be like. But in general, if you look at the long-term average, the best time of the year is August, because you got both the non-meteor shower random meteors. That's when they're close to their peak, although July is a little bit better. And then on average, the Perseids adds enough that overall the Perseids provide the most reliable peak rate throughout the year. And they're the most famous. That if you want to mention, one particular meteor shower that stands out for people working meteor scatter, it's the Perseids. But there are many of these others that are also quite important to people. And naturally, you kind of follow the calendar, and we'll get into some of the software apps for that in a second. But there are people that really into meteor scatter that they'll schedule their vacations so that they're off work on during the Perseids on August 12th. What about during the day? Well, it turns out there's a very specific time of day where sort of the sweet spot for meteor scatter work. And unfortunately for me, it's early in the morning. I'm not really a morning person, but I've circled in red this time slot that it's, you can see the overall trend there, but in terms of sort of return on investment of wanting to get up while there's activity, the best time to try to work meteor scatter is in this 2-hour window that's centered around dawn. And the reason for this is it's the time when your part of the Earth is rotating, turning into the direction of the orbit of the Earth as it's orbiting the sun. And this increases both the rate and relative velocity. Then as you can see on the chart, there's a rapid fall during the day. Basically, my experience is it falls off very rapidly, that if you've slept late and missed 7 o'clock, then you might as well wait till the next day. And there is and you can also see there's a slow rise after midnight. So here's an example. The earlier maps were from PSK Reporter. This one's from DX Maps. And if you're familiar with the color coding scheme there, this should be familiar to you. But if you look closely, there's 3 colors on this map. I think there's green, red, and blue. And the green is for Tropo, the red is for Sporadic E, and the blue is for Meteor Scatter. And these are, based on reports where it's either suspected or reported to be a particular type of propagation. Just these are stations that are spotting. There's no guarantee that these people actually had a CUSO with each other. It's just that someone left their, some of these are going to be CUSOs, but some of these spots are just that someone left their radio running, and WB5GVY there in Texas left his radio running and happened to decode a signal from KE8FD. But it's an indication of what's going on that day and how good the particular activity is, or meteor shower is, for that day. This was at rather late morning. It was 7:37 a.m. In December. So let's talk about meteor scatter modes over time. There's some history here. The very first QST article on meteor scatter supposedly was in 1953. I've only skimmed the article, but my understanding is that there was mention of meteor scatter that was conducted on 15 and 20 meters at the time, using both CW and AM phone. The heyday of meteor scatter apparently was soon thereafter. In the 1960s, there was high-speed CW was quite popular. They had different transmit receive periods between 1 minute and 2.5 minutes. They were sending up to 1,200, I think even higher than 1,200 words per minute. How do you do that? I've never done it, but my understanding is they used a memory keyer. And so they'd program the memory keyer with the exchange, and then they sped it up. I don't know if they had to modify the memory keyer to do that, but supposedly that's how it was done. And then on receive, they used specially modified cassette tape decks where they were able to modify the playback. And so I think the way this used to work is that you would record to your cassette deck during the interval when your partner was transmitting, and then you would turn on your memory keyer and try to play back what you had just recorded while you're sending out your transmit interval. Things changed in a major way with 2001, the debut of the WSJT weak signal Joe Taylor suite of software, where it was introduced a new mode called FSK 441. The name comes from the fact that it's at 441 baud. It was a 4-tone frequency shift keying mechanism, and it used 30-second transmit receive periods. Some people still use FSK 441, but not that many that I can tell. In 2017, the WSJT-X software suite introduced what's the main mode of meteor scatter nowadays, which is called MSK 144. The MSK stands for minimum shift keying. It has 144-bit frames, and from that is where they get the name. It's actually at 2000 baud. The interesting thing about MSK 144 is that it uses high-tech error correction circuitry. It adds 48 bits of low density parity check redundancy to each frame. So of that 144-bit frame, 48 bits are error correction. And so it's not just error detection, it's error correction, that there's enough redundancy built into the 48 bits of the LDPC code that the software attempts to not just detect that there was a problem, but that it attempts to extract what the original intent was. And MSK 144 uses 15-second intervals, as we saw in the video. MSK specifically was designed for this, the way meteor scatter contacts work, with fast deep fading appropriate for these very short 1/10 of a second bursts of when these ionized meteor trails have a very short lifetime. We've already talked about the CUSOs have this alternating interval between transmit and receive that lasts 15 seconds. Mentioned the error correction code. It's a form of forward error correction, FEC encoded, and all that's put into the 72 millisecond long packet. And as I mentioned, that's repeated like 200 times in each 15-second interval. And so we saw before how the call signs, the grids, signal reports as appropriate to where you are in the middle of the CUSO gets packed into that 144-bit frame and sent out. And as you heard it, I think of the not that I've ever heard a Navy Gatling gun in person, but that's sort of my mental model of what it sounds like when you hear a local transmitting this bada 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 thing for 15 seconds long. Now the receive decoder tries to code every one of those 200 packets that are sent in there, and it will only display a decode if the information was received without any error. And by without any error, I mean that after the error correction code has been applied, they were able to say with confidence that this is what was originally sent. This is in contrast, and again, I've never used FSK 441, but my understanding is that FSK 441 would display decodes even if there were errors. And some of the diehards that still stick with FSK 441 believe that this makes for more confirmed contacts, that the operator is deciding whether or not a particular exchange was valid or not, as opposed to the software deciding that there wasn't an error. Okay, so let's get into some practical matters. For meteor scatter, you want to use horizontal polarization. Everyone else is using horizontal polarization. You're going to have a cross polarization penalty if you don't. There may be other reasons for doing that, but everyone's using horizontal polarization. You want to use a beam. Beams help with noise problems, which we'll get into, but noise problems are a big deal. Most people are using MSK 144. 6 meters is considered an optimal band for meteor scatter, and it's by far the most active. There are people that operate meteor scatter MSK 144 on 2 meters, but it's there's less activity. It turns out that you can even go higher than 2 meters, but it turns out it's increasingly more difficult and far less active. And the reason for this is that the signal strength of the refracted radio wave decreases, and the duration of the length of the ionization trail decreases with increasing frequency. I've never tried it, but there supposedly are folks that do 10 meters meteor scatter. I've read that they use what's called the JT9G fast mode, and that the reason you don't use MSK 144 is that there's a 300 baud limit on 10 meter data modes. All right, more practical matters. So the effective beam width that you'll realize on meteor scatter appears to be much narrower than it is for sporadic E or tropo. And I guess I didn't really talk about it, but in sporadic E, sometimes the direction the antenna's aimed doesn't matter that much. That it really, for sporadic E, it's more, I think, where the sporadic E clouds are than anything else. And because on sporadic E, I've had contacts off the side of the beam and back of the beam, and it worked just fine. But you can't get away with that on meteor scatter. And because of the narrow beam width, except for major showers, this can be problematic for making CUSOs by just calling CQ into the blind, into the void. That and while you can make a CUSO that way, generally it's often the case that people make schedules or announce that they're calling via some form of social media. And the most famous of these is Ping Jockey, which we're going to dive into several foils about. I also may abbreviate that as PJ, but I'm talking about Ping Jockey Central. There's another web presence. This is somebody's call. Oscar November 4 Kilo Sierra Tango. He runs a number of chat rooms, old school chat rooms. Ping Jockey Central is also old school, as we'll see in a minute, but there's these chat rooms and several chat rooms for the on4 KST, and the one that's for meteor scatter for us is 50 megahertz IARU region 2 chat. There's also multiple work groups on Slack. There's one called VHF chat. And then I recently discovered there's other chat rooms for there's two clubs down in Austin that also have Slack chat rooms where some meteor scatter work is talked about. And then you can also use JT Alert messaging just like you do on FT8 if you've ever used that. I think that JT Alert falls into the category, they call it a QSO helper. Okay, so more practical matters. This is a chart of weak signal to noise ratio limits in decibels for a 2.5 kilohertz bandwidth, and it's rated from single sideband to FT8. And of course, the miracle of FT8 is that it's got this great signal noise limit of minus 21 dB, and MSK 144 has only a signal noise limit of minus 8 dB. And the thing is that noise that's a non-issue on FT8 for sporadic E can be a big deal for meteor scatter work. That local noise can be a very big deal. And depending on the noise source, it can effectively limit your workable bearings. And it's also the case that daytime noise can bring showstopper noise. So even though the peak dies off, another reason why you're not going to want to work meteor scatter during day is often the noise level is higher. So some odds and ends of practical matters. We're going to look at two types of success factors over the next few foils. And we'll drill into this. One of them, this is actually talking to the third bullet first, that there's a bunch of tangible factors that improve your signal to noise ratio, and there's intangible factors that increase chair time. And to circle back to the first bullet, it sort of takes two to tango. Of course, this is true for all amateur radio modes, that sometimes it's the other station that's doing the heavy lifting, if you will. And that's probably the case for the 15 states I've worked, because my station is so modest, and we'll get into what a more serious station looks like. So the strengths and weaknesses of both QSO partners matters in everything that we're going to discuss here. There's also, I want to mention, there's what I would call a network effect. And by what that I mean by that is that the number of ops that are actually working Meteor Scatter at the moment can have a very strong bearing on how much activity, your ability to make QSOs. That there's people that aren't on Meteor Scatter that it's very quiet, but on major showers they crawl out of the woodwork. And so not only, it's not just the fact that you're in the middle of August, it's the fact that everybody took off on vacation in order to work Meteor Scatter. You'll also see this network effect with contest weekends and holidays. And then sort of the reverse effect is, people go eat breakfast around 7 o'clock. And so there's not that many people in the chair when breakfast time rolls around. And then if there's a large sporadic E opening, then that tends to suck everybody away from Meteor Scatter work. So let's look at things that have bearing on signal noise ratio. And again, many of these things are old hat to any mode, but I've sort of pointed out specifics for Meteor Scatter or specifics for 6 meters as well. Ideally you have a beam antenna. I have a 2-element Moxon antenna, and but the sort of most common thing that you hear from big guns is they'll have like a 5-element loop fed array or more. You want to have an outside antenna. That's not what I've got. I'm inside my attic, but and the problem with that is you've got attenuation. I've read that you probably have 3 dB attenuation just to go through the shingles of the attic. And of course, the attic has a problem. There's lots of near field metal. And so you can get detuning effects and, what's your antenna pattern with all that metal around. And so your outside antenna, you get increased distance from the home and the attic noise sources. Now, you want to have a height above average terrain of 30 feet or more. Now, it turns out that I've got that. I've got a very tall attic. And so that helps me in that regard. 100 watts is considered QRP on MSK 144. And the major players are going to be running 500 watts or more. That many of them are running the maximum power. Another thing that comes in quite handy is mast mounted low noise amplifier. And I have one of these and it helps. And there's sort of 2 flavors to these depending on whether or not you're running low power or high power. The low power versions are referred to as being Vox operated. And then the high power ones, you need to have a device called a sequencer that makes sure that the receiver's turned off when you're transmitting. Ideally, you have a low noise QTH. Farm or ranch country is best. And the worst thing is to be located to something that is industrial, scientific, or medical. You'll hear people talking on the air. They'll say, hey, the hospital near me started using the one of the imaging machines, and that's when the hospital starts up doing the CAT scans, then that's the end of the MSK 144 for that op. But even beyond that kind of thing, you might want to look into scheduling other home noise sources. Like, for example, I have my setback thermostat set to just turn off everything, air conditioning, heating, no matter what day of the year, in order that there's a quiet interval during that period of 2 hours around dawn. So those are signal noise ratio thing. There's also chair time. And the specifics here for Meteor Scatter is that up before dawn needs to be easy for you. And if you're not a morning person, then Meteor Scatter may not be for you. I've gone through periods where I tried to get up early and was able to work things, but it's hard to get up regularly that time of day for some people. And then we talked about patience, that You know, how many times on FT8 have you worked somebody and you missed one sequence and they're gone? Well, these are not future meteor scatter people. That you have to have a great deal of patience to work meteor scatter, and you have to stick with it if you want to complete the contact. And sort of for all the reasons of getting up early, hopefully you have your significant other doesn't have a problem with you getting up at that time of day. And of course, it helps if you have a flexible work schedule and you can schedule your time for the meteor showers. Some more focused things on the software at this point. You're similar to other digital modes, you need to have your clock accurate within 2 seconds. Your rig should be accurate within 200 hertz. So you want to occasionally zero beat, you know, with WWV, or you need to have a GPS discipline oscillator you can beat against and calibrate your rig. Previously mentioned, the WSJT-X is the most popular software. There are other alternatives. I mentioned you can use the older WSJT-10 software, which is still available and has FSK 441. And there's also a program called MSHV, which I have not used, but is also another popular software for meteor scatter. So let's dive in. If you select the MSK 144 mode, I've highlighted in red some differences compared to what you'd see for FT8. Initially, you want to set a frequency tolerance of 200 hertz and the received bandwidth to 1500 hertz. I'm sorry, not the bandwidth, the receive frequency to 1500 hertz. And you want to select a transmit receive interval of 15 seconds, although you can negotiate differently with your QSO partner, but 15 seconds is a standard. In the two boxes here is something about the calculated beam heading. And if you've ever used FT8, you'll be familiar with the azimuth AZ setting, that if you enter in the DX grid box, the grid, and this will auto-populate when you double-click on somebody that's transmitting their grid, but you can also manually code in the DX grid, that the program will calculate for you the azimuth for the heading. And this is considered to be the best heading to use when you're in the meteor shower. But it turns out if it's not a meteor shower, there's something called hot A and hot B. And that's this, as this red box on this particular slide shows, you'll see that there's A:79, and that could have been a B colon as well, but the software calculates whether only one is the best, and the one that's there that's called odd, you would say you had a hot A bearing of 79 degrees. And hot A is, turns out it's an offset south of the direct azimuth setting, while hot B is north of direct setting. And this is, my understanding is this is based on, it's a function of both the distance to your QSO partner, the time of day, and a bunch of empirical data gathered from back in the 50s. There's some extra boxes here that normally you can leave unchecked. SH stands for short format. It's also abbreviated SH. The short format is sometimes used on 2 meters when it's requested by a QSO partner. It's generally not used on 6 meters. What happens is that you're probably familiar with the transmit periods. Over here, the TX3, TX4, TX5, when you're in short mode, those are sent with, instead of the 72 millisecond interval, they're sent in 20 milliseconds. So that means they're sent 750 times instead of the 200 times when short format is not used. But you have to turn on SWL if you're trying to decode short format messages that are sent by other than you and your QSO partner. Contest mode, CM, is occasionally used, even when there's no contest. And for some people, this is a popular option. And on social media, they'll just say, hey, use contest mode. It turns out it requires only 4 exchanges instead of 5. And so there's this, chance that you'll complete the QSO when you wouldn't have in the 5th, maybe the meteors went away, that kind of thing. It's not usually that often, but you'll see it. And of course, if you've used FD8, you'll recognize the exchange saying CQ test, and that's just short for the contest mode. This is toggled. It's not on the screen we've been looking at. It's in the advanced tab under settings in WSJTX. On social media, you'll sometimes see the letters CMSH, and what they're talking about is contest mode and short format, that they want you to use both. 50.260 megahertz, or just 260 for short, is the calling frequency, and that's where most QSOs happen. Occasionally, a nearby frequency will be suggested. This arises when, for some reason, there's local QRM. It also arises during meteor showers when there's more people that have crawled out of the woodwork. And so one way to, more people to operate is to move off 260. Where I live in grid EM10, there's really only a few stations that are regularly active. So this is not too much of an issue, doesn't happen too often. Occasionally I'll hear people from down in Dripping Springs or San Antonio. Local to you, there's station W4IMD is a big gun on Meteor Scatter and is a regular. Let's see. There's this interesting QSY feature in WSJTX. I put a red box around it in this foil, that if you enable that, then and you change the frequency to like 270, then the software split listens. It starts off transmitting on 260, but it split listens on 270. And if someone responds to you in 270, the software automatically switches the QSO over to 270. So you even though you were calling on CQ, but you were in this special mode, the rest of the conversation, once someone replies to you, happens on the QSY frequency. This is a screen grab of Ping Jockey Central. This is sort of where a lot of Meteor Scatter activity happens. We'll zoom in on a few things here. This is the URL to go to Ping Jockey Central. You have to register, but it's trivial. Your posts, once you, the registration is just to get your grid square and your name. The example of the way this is used is that if I'm going to call CQ and I've got my beam pointed to the west, then I'll just make a post on Ping Jockey that says CQ 262nd west. And people understand that I'm aiming west and then I'm on the second sequence. Then when you see 260 on Ping Jockey, again, it's talking about the calling frequency. You'll also see a string that begins with 14. Well, that's a 2-meter frequency, although it can be confusing around 1400 UTC. But in general, the calling frequency on 2 meters is 144.150. If you don't like the old school web page look, there's a software client by November 5 Tango Mike that puts it more in a conventional software app on Windows. Let's see. So here was the beginning of a CUSO I had with W4IMD, and I was going to try to point out some highlights from this. So down here, of course, the thing goes from bottom to top in terms of progression of the time, as you can see, from 338 up to 353. So at 338, W4IMD posts onto the ping jockey that he's calling CQ second. And I see this, and so I aim my beam at the calculated hotspot for EM84 because all he entered was CQS 262nd, but because he's registered, it automatically displays his grid square here. And so I enter EM84 into the software, and it calculates the hotspot for EM84, and that's where I aim my beam. And then at 350, I post a spot that, so the ... GE is just me saying good evening. Everything that was in front of this was the spot. So what this was that I copied from the band activity window in WSJTX and pasted it into the ping jockey message box. And so this lets a W4IMD know that I'm hearing him and that he has a signal strength of -1. And this is sort of an informal way that he knows that he's being heard here. And probably at this point, he would aim his beam and refine his beam heading to points specifically at me if he was off axis a little bit. And then here we see at 3:52, about 2 minutes later, he just says, "Good evening, Bennett." And so he's just letting me know that I've got his attention. And it sort of implies that he's probably going to be looking for my response, because there's an implication when I posted the spot that I was probably initiating a call with him. So the next line here, you notice there wasn't, from the good evening to 73, thanks, great copy, only took a minute. So this went very quickly. Nothing was posted during the CUSO because that's not considered kosher. And he would not have posted this if he, unless he, believed that we had both exchanged Rogers, which we'll get into on the next foil. It also implies that I'm in his logbook and we can stop. And he wouldn't have posted that unless all those things were true, because he's experienced at this. So here's the same thing, but in the view from WSJT-X. The green line shows that I'm receiving his CQ. I began transmitting to him, calling him with my grid square. And about a minute after that, I did the post to the ping jockey. Then we see that he gives me a -1 report. Next, I give him a -9 report, and then we have his Roger in 73. And once this Roger is received, then the CUSO is complete. And then I give an optional 73, and he gives a courtesy 73 signaling we can stop. There is sort of an etiquette to ping jockey. And I would recommend that if you want to get into this, that you observe for a few days to see what's normal. The main thing you don't want to do is you don't want to post about the progress of what I'm calling, it's my term, a word credit CUSO in progress. And you occasionally see people that accidentally will do this who don't know better. Basically there's some things that are okay. It's okay to post those CQ spots, and it's okay to post after a CUSO to say 73, but you don't want to post any mid CUSO spots, and you don't really want to post mid CUSO spots if they include RR73. The problem with that is it's considered that you acknowledge that you got his Rogers, and you're not supposed to do that, out of band. if you will, not on the 6 meter Meteor Scatter CUSO. And then lastly, I'd say that there's, if you follow Ping Jockey, there's sort of 3 classes of banter, and it varies depending on who's involved. That when you're a newbie on Ping Jockey and you let them know that you're a newbie, then there's this high level of banter that people are very outgoing and friendly, and you're encouraged at each step of how to do stuff. So there's a high level of banter. And then when there's the second sort of class is if you're not a newbie and there's like an award credit CUSO going on, it's entirely frowned upon to have any kind of banter going on during that CUSO. And then confusingly, there's sort of a third class of banter, and that's just old friends tinkering. And and this kind of confusing when you first start following Ping Jockey, because there's these guys, they got upset when someone talked about mid CUSO banter, but then a few minutes later, they're talking all over the place in the mid CUSO. And what's going on is these are people that have probably worked each other, 30 or 50 or 100 times before. And they're like just, tweaking something, or they're just saying hello that morning. And so again, the mid CUSO banter is normal for them. All right, so it was a long journey to get here, ran a little long, but here again is our summary of takeaways that 6 meter radio sports is very grid centric and unique compared to HF. It can be modest station friendly. There are the important propagation types include Sporadic E, Meteor Scatter, but it also includes Tropo and trans-equatorial propagation. Meteor Scatter is quite involved, but it can be exciting. And hopefully you found that, as I did, that 6 meters is the magic band. And that's the end of my talk. You'll hopefully enjoy the references here. There's all sorts of detail.